Lesson 2 is about multiplication and division. We're going to again talk about equivalent equations and balanced equations. The goal is always to solve for a single positive variable. So we're going to use much of the same procedure as we used with addition and subtraction. You can pause the video and read through this first screen if you need to. Putting it in action again. This time, the vertical method is the method that is shown in the book. That's why I tried to make sure that we did that also with our addition and subtraction. So we are going to solve negative 4x equals 1. So what this means is we're multiplying x by negative 4, and we want to get x by itself, so I'm going to divide negative 4x by negative 4. Keeping it a balanced equation, I need to do that on the other side as well. So now I'm going to change to another color so you can really see what we're doing here. Negative 4 over negative 4 would give me a positive 1. So I'm left with x on this side. 1 divided by negative 4 will give me a positive 1/4. Now it is always good when we are solving for a variable, and you could do this in the addition and subtraction as well, to go ahead and check by substituting it back in. So if I go ahead and I say negative 4 times my x, which I think is negative 1/4, that was my solution, does that in fact equal 1? Well, 4 goes into 4 one time. Those cancel it out. And negative 1 times negative 1 equals 1. So yes, it did check out. Moving along, oh, that was a pretty color, but moving along, we'll go to the next one. This time, we have x divided by 5 equals negative 30. So I want to go ahead, I'm going to rewrite it so it's easier to read with, oh, my goodness, I don't know what was going on there. Hold on here. Somehow we got a very, very fat pen, too. I don't know how it changed like that. Let's see what we have now. All right, we have x over 5 equals negative 30. We've got a different color blue there, too. Now, x is being divided by 5, so I'm going to do that opposite operation, and I'm going to multiply by 5. But if I multiply this side by 5, I need to keep it as a balanced equation, so I need to multiply this side by 5 as well. 5 goes into 5 one time, leaving me with just my x on this side, and negative 30 times 5 equals negative 150. I can do my check is negative 150 divided by 5. Is that equal to negative 30? And it is, so I've solved that correctly. Now this time we have a reciprocal, or we have a fraction as our coefficient. So we need to multiply by the reciprocal to get that equal to 1. So I'm going to multiply, watch that sign, I have a negative there, so I'm going to multiply by a negative 3/2. I'm going to fix my half there about it. If I do that on one side, I have to do it on the other. I should have rewrote this so it was a little easier to see this. That is a negative there. So my 3 goes into 3 once. Notice I still have my negative there. My 2 goes into 2 once. I have a negative 1 times a negative 1, so that equals positive. So I'm at a positive 1m. I don't have to write my 1. Now I can go ahead and I'm going to write it over here so you can see it a little bit better. We're multiplying our negative 3/2 times 10 on this side. So it's getting pretty sloppy. Get rid of this other one so it's a little easier for you to see as I do some renaming here. So 2 goes into 2 one time. Wow, we're having a little freak out with the marker today. And 2 goes into 10 5 times. So we have a negative 3 times 5, so we get negative 15. And we also get back to our bright blue. Very confused what's going on here. Let's go ahead and check this one because this was confusing just to even listen to. let's do 10 equals negative 2/3. I'm going back to my original sentence, the type sentence here, and I'm going to go ahead and substitute negative 15 into here. And I want to see, this is my check, see if this is going to, if this is in fact a true statement. So 10 equals, 3 goes into 3 once, 3 goes into negative 5, or negative 15, negative 5 times, negative 2 times negative 5 gives me a positive 10. Now we have the properties of equality, and these are all the properties that we have been talking about. You'll notice in the first one, the addition property, it says if A equals B is what we want our final to be, I can add C to both sides and that would still be true. The subtraction, I can subtract C from both sides. The multiplication, I can go ahead and multiply as long as I'm multiplying from both sides. And for division, I can divide each side by the same number. This is properties of equality or balanced equations. So this time we're going to solve a real life problem. We're going to be restoring a single picture on a roll of movie film. It's called a frame. And the motion picture studios tried to save some older films from decay by cleaning and restoring the film frame by frame. This process is very expensive and time consuming. The usual rate for taking and projecting professional movies is 24 frames per second. Find the total number of frames in a movie that is 90 seconds long. So, what we need to set up is the total number of frames in the movie over the total numbers of seconds in the movie, and that will give me the number of frames per second. We know the number of frames per second already. So we know we're going to be solving to equal 24. Now, we also know, we can also find in this, that the total number of frames in the movie were 90 minutes long. So, the total number is going to be 90. And we're going to go ahead, oh, I'm sorry, I skipped one part here. Let me go back, get rid of my 90. And we have that the total number of frames in a movie that is 90 minutes long is what we're supposed to try to find out. Now, to find the total of seconds in the movie, we need to multiply 90 by 60 because each minute is 60 seconds. Okay, so, and our other one here was our number of frames per second. So we need to do the 90 times 60. We want to know the total number of frames, and we're going to make that 90 times 60. So now our new sentence, I think I have a blank page next. Let me look. Nope, I don't. I'm going to put a new page in there real quick. So we're going to have, we had x over 90 times 60, 90 frames, 60 seconds each, and we had that there were 24 frames per second. So to go ahead and solve this, first I'd have to simplify. So I would have x over 5,400, that equals 24. I want to get x by itself, or solve for a single x, so I don't want it to be divided by 5,400. I'm going to multiply it, because that will give me my isolated x. But if I do that on one side, I need to do that on the other side as well. So when I do that, I'm going to get a whopping, and you could do this on your calculator, it's going to be 129,600 frames. All right, going back to that problem again, we're going to do letter B. So here's that the same information we had before, and this is what we figured out, 129,600. So a 90-minute movie has 129,600 frames. So if a worker can restore 8 frames per hour, how many hours of work are needed to restore all of the frames in a 90-minute movie? So we're going to do Y this time, the number of hours of work, and use that from and we're going to use what we found out from part A. So the number of frames restored per hour is going to be 8 frames. We want to know that what we're trying to find out is the number of hours of work, and they said to let that be Y. And then from our solution from letter A, we found out that the total number of frames in the movie was 129,600. So this is actually 8Y if I simplify it. So I don't want to know how many 8Ys are, I only want to know 1Y. So I want to isolate my variable, which is going to be Y. And then 129,600 divided by 8 is going to turn out to be 16,000, that's a better comma there, 200. So 16,200 hours of work are needed for this project. Now you know why it takes so long to get a movie to be done. And I believe, oh, we have one more example here. We're going to talk about similar triangles. So similar triangles, you've done this back in even 6th grade. We're going to talk about a ratio. Okay, so we're going to be setting them up in a fraction form. So we know that the length of this side here, AB, is equal to the ratio of the length D, or can make an equal ratio to the length DE. I'll use a different color here, we'll see. And so then we also have, let's use this side, the AC side, and its corresponding side would be the DE. Now remember, I know that because I'm checking out the arcs. So the green one was where the 2 arcs pointed, and the blue side was where the single arc pointed. Those would be our corresponding sides. So hopefully I have another screen to show this one. All right, so this time we're going to try to figure out what the length of AB, this side right here, and they're going to call this side X. This is the one we're trying to figure out. So we're going to say X, the length of AB, we don't know that one, but its corresponding side, we're going to set up ratios here. So the corresponding side to AB is side DE. So I can say X over 7. Now I'm going to do another set of corresponding sides. So I'm going to do, let's go ahead with, I'll set it up the same as they did. So they did BC. So BC is 10. And BC corresponds with the 3 arcs here. So that corresponds with 5. Now, because these are equal ratios, we can do this 2 different ways. We can go ahead and we can do cross multiplication, or we can multiply by the reciprocal. These are workable numbers, so we'll go ahead and we'll set this up as cross multiplication. So we're going to do 5x, because they're equal, we know that 5x then should equal 7 times 10. 5x equals 70. Divide both sides by 5, and we come up with x equals 5 goes into 7 one time, 5 goes into 20 14 times. So our final answer is x equals 14.